Good morning. My name is Mark Schisler, and I'm one of the project managers for this team. Before we begin, I'd like to take the opportunity to welcome everyone to Caltrans Pomona. This team has worked hard over the last several months, and we are very excited for you to be here today for us to present our work. Caltrans District 8, in partnership with the City of Lake Elsinore, proposes to improve the existing interchange at I-15 and Railroad Canyon Road, and to design a new interchange in close proximity to Franklin Street, and overcrossing to the I-15 just north of Railroad Canyon. The City of Lake Elsinore is located in Riverside County, the state of California. It's approximately 70 miles southeast of Los Angeles and is nestled on the east side of the Santa Ana Mountains. The interchange at I-15 and Railroad Canyon Road is currently experiencing operational problems due to periods of high traffic volumes. The combination of the current tight diamond geometry and closely spaced ramp and city street intersections produce congestion during morning and evening commute. Bottlenecks are generated by vehicles traveling westbound on Railroad Canyon Road to northbound I-15, AMP, and southbound I-15 to eastbound Railroad Canyon Road, PMP. The backup on the southbound off-ramp overflows onto the I-15, causing not only operational delays to the freeway, but it's also a major safety hazard. Railroad Canyon is also experiencing high through traffic volumes that contribute to the congestion. Lake Elsinore was the third fastest growing city in the state of California last year. It experienced a 90% population growth in just the last 14 years, and is projected to continue this trend through the year 2040. The city's general plan shows locations of future commercial, residential, recreational, industrial, and public institutional land development. The site-specific areas, shown in gray, contain mainly residential zoning. Without improving the city and state's transportation infrastructure, vehicle hours of delay, travel times, average speeds, safety, and other traffic performance measures will continue to degenerate if the situation is not properly mitigated. Two Cal Poly Pomona senior project teams delivered a project study report for their respective interchange projects. Due to the close proximity of the two project locations, both teams worked closely together. Our team was responsible for the improvement of the existing interchange at I-15 and Railroad Canyon Road, and I'd like to have them introduce themselves now.
Andrew Hall, Traffic Lead.
Evan Ferrer, Traffic.
Ryan Gosliga, Geometrics Design Lead.
Kevin Casado, Geometrics Design.
Kevin Mock, Geometrics Design.
Jonathan Burke, Structural and Environmental.
Jenny Han, General Civil and Environmental.
And I'm Brandon Wong, the other co-project manager. The I-15 Improvement Project Study boundary includes adjacent interchanges above north and south of Railroad Canyon Road, Main Street to the north, and Bundy Canyon Road to the south. Within the study boundary, the two senior project teams define their design boundaries. The Railroad Canyon Road design boundary includes a greater emphasis on local street intersections, including major arterials at Railroad Canyon Road and Diamond Drive, as well as the frontage road at Grape Street. Level of service is a quantitative measure used to relate operational traffic conditions at a particular type of facility. The team simulated 2040 traffic volumes at the Railroad Canyon Road interchange with Synchro, using an intersection control delay base scale from A through F, where A represents an intersection with free-flowing movements and F represents an intersection with force-flowing movements, where the demand is greater than capacity. The Railroad Canyon Road network projects a level of service F at all intersections in the year 2040. The project's purpose is to improve the existing and future traffic congestion while enhancing safety at the Railroad Canyon Road interchange. With this purpose, the team brainstormed 4 city, community, and Caltrans needs. The first 2 are to accommodate for the city development and growth for access to the I-15, as well as to improve the current freeway operations. Next is to account for the future widening of the I-15 corridor. The future plan for the corridor is to comprise of 3 existing mixed flow lanes and the addition of 1 HOV lane in each direction. And the last need is to provide bicyclists and pedestrians with safe accessibility. Although the purpose and needs were developed in the early stages of this project, they were crucial in guiding the team during the duration of this project. Next up, Ryan will discuss our alternatives considered.
Thank you, Brandon. I'd like to continue our discussion with an overview of alternatives considered for meeting our project needs. Following the preliminary analysis of the project study area, a comprehensive list of alternatives were developed by the team. This list was then analyzed by our geometric designers alongside our traffic team. This involved extensive reference to the Highway Design Manual as well as Lake Elsinore standard plans. This team sought innovative designs, and I'd like to discuss a few of them now, as well as their advantages and disadvantages as they pertain to this project. Depicted here is a key design element to a SPUI. I'm sorry, let me introduce this first. It's a single-point urban interchange, also known as a SPUI. Depicted here is a key design element to a SPUI. It's a single centralized intersection for all traffic moving in and out of the interchange. Next to the advantages and disadvantages of this design. The most significant advantage that this offers is the ability to converge ramp intersections into a single point, thus allowing the elimination of non-standard intersection spacing at the site. Next, the continuous flow interchange, also known as a CFI. This design incorporates a crossover movement of left-hand turns onto the opposing side of traffic. This allows for yielded movements onto the interstate facility. These movements offer a significant operational increase due to the elimination of excess vehicle queuing. Next, the diverging diamond interchange, also known as a DDI. This design incorporates a braiding of all approaching traffic prior to the interchange. Similar to the CFI, this also allows for yielded movements onto the interstate. The advantages and disadvantages to this design mimic those previously found in the CFI. Hook ramps were also considered for this project and are displayed here. These designs were ultimately rejected due to their inability to conform to geometric standards, as well as improve local circulation, particularly at Railroad Canyon Road. Other alternatives included a roundabout variations, split diamond interchange, as well as a collector-distributor system. Our roundabout variations were rejected due to a spillover effect from the adjacent intersection. As shown here, you can see a total breakdown of the roundabout. In addition to these, our split diamond interchange, as well as our collector-distributor system, in collaboration with our Franklin design team, were also rejected due to the significant impacts to right-of-way, as well as increased structural costs. With consideration of all project needs and existing constraints, it was determined that the CFI, the DDI, and the SPUI be selected as viable project alternatives. With these alternatives selected, the team could continue producing our project deliverables. This included a project study report, or PSR, geometric approval drawings, intersection control evaluation, or ICE, traffic analysis, environmental assessment, construction staging, advanced planning study, and finally, a cost-benefit analysis. I'd like to pass it over to Kevin Ferrer, who will discuss a little bit more about these project alternatives. Deliverables, sorry.
Thank you, Ryan. We went over the following items when performing our detailed analysis and design of the selected alternatives. They vary from geometric design to traffic analysis to supporting materials required in the PSR. I will go over each, starting with the GAD. A geometric approval drawing, or GAD, is used to identify major design elements of an alternative by producing a geometric approval drawing, or GAD, is used to identify major design elements of an alternative by producing plans that showcase horizontal alignment, profiles, typical cross-sections, and any design exceptions. A GAD also includes supplemental information such as super elevations, topographical features, bicycle and pedestrian compliance, and traffic volumes. Next is ICE. We performed a new type of intersection control selection procedure. It is known as intersection control evaluation, or ICE. ICE is a new directive issued by Caltrans' traffic operations. The directive applies to all highway intersection projects, whether new or for improvement. Intersections control type listed by ICE include stop, yield, and signalized alternatives. We assess each intersection using a two-step process, a basic assessment and an engineering analysis to gauge its feasibility. This is alongside nearby intersections with their control alternatives. For example, when looking at this intersection, we assessed that the stop control will not work. Therefore, in our engineering analysis, we considered the yield and signalized alternatives. Our traffic analysis results concluded that the yield would fare worse than the signalized alternative. Therefore, the signalized will be selected for this intersection. There's no guidelines to creating a ICE document. Therefore, our team created reports that follow the directive. For all of our intersections, we've analyzed that they would all be signalized. Next is traffic analysis. Our traffic analysis consisted of creating a model to simulate and analyze our existing and future conditions of our alternatives. Next is vehicle turning. All of our alternatives must be able to take heavy truck traffic, turning movements. We assessed our horizontal alignments using auto turning, a program that overlays the footprint and path of a variety of vehicles onto our designs. For our case, we use STAA long, a type of semi-trailer truck that is 74 feet in length. Next is advanced planning study. An advanced planning study, or APS, is used to document the scope and cost of any structure work for our alternatives, such as bridges or retaining walls. An APS was created for each of our alternatives. And finally, environmental. I'll pass it on to Janet for that one.
Thank you, Kevin. Because of the ever-growing concerns with environmental impacts, it was crucial to perform an environmental assessment on our project study boundary. The Preliminary Environmental Analysis Report, also known as a PAIR, is a Caltrans directive that we used for this environmental assessment. It's a concise report that documents issues and assumptions to be addressed by NEPA and CEQA. The composition of these significant environmental studies, including but are not limited to air quality, noise study, water quality, hazardous waste initial site investigation, cultural aspects, and community impact assessments were key variables in helping us to determine what type of documentation would be needed. The findings of the PAIR anticipate that a negative declaration for CEQA and an environmental assessment for NEPA declared that a finding of no significant impact would be the appropriate environmental assessment for our project. For each of our viable project alternatives, we will highlight geometric design, traffic analysis, as well as a cost-benefit analysis. To begin this discussion on our project alternatives, I'd like to pass it on to Kevin Casano.
Thank you, Jenny. I'll now be talking about our continuous flow interchange alternative. The final horizontal for the CFI is shown here. There's a lane addition to the northbound off-ramp and southbound on-ramp, and a lane addition in each direction along Railroad Canyon Road. This lane addition would serve as a receiving left turn pocket for the crossover movement. These pink lines highlight the pedestrian and bicycle access routes, which are in compliance with the DIB 82-5. There are a few design exceptions for the CFI. The short intersection spacing is less than the recommended length of 400 feet, and the skew of the ramps is less than the recommended angle of 75 degrees or greater. Now, here's a short simulation of how traffic would flow through the CFI using the projected 2040 volumes. We found the 2040 level of service results increased to a B, C's, and a D in the AMP, and a C and D's in the PMP. To accommodate for the widening of Railroad Canyon Road, an APS was created. The only structure work needed is the addition of retaining walls with tiebacks to each side of Railroad Canyon Road. The I-15 bridge would be kept the same, thus keeping the vertical clearance at 16 feet 8 inches. A preliminary cost estimate was done. Major items included roadway, structure, right-of-way, design, construction and administration, and some contingencies. The total cost of the CFI is approximately $36 million. The benefit of each alternative was based on the total reduction of these factors compared to the no-build. For the CFI, there was a 62% reduction in total vehicle stops, an 82% reduction in the total vehicle delay, and an 84% reduction in the total fuel use and carbon dioxide emissions. These savings were then assigned a monetary value for each year of the facility's 20-year design life. A present worth calculation then determined the total benefit in 2014 dollars. The total benefit of the CFI is approximately $69 million. Now, I'll be discussing our diverging diamond interchange alternative. The DDI is very similar to the CFI. All lane additions match that of the CFI. The only difference is the braiding movement of through traffic. These pink lines also highlight the pedestrian and bicycle access routes, which are also in compliance with the DIB 82-5. The design exceptions also match that of the CFI. Now, here's a short simulation of how traffic would flow through the DDI using the projected 2040 volumes. We found that 2040 level of service increased to a B, C's, a D, and an E in the AMP, and C's, a D, and E's in the PMP. The APS also matches that of the CFI. The total cost of the DDI is approximately $36 million, and the total benefit of the DDI is approximately $49 million. The benefit difference between the CFI and DDI is due to the level of service being lower than the CFI. Now I'll pass it on to Kevin Mock to explain our final alternative.
Thank you, Kevin Castaldo. Our final alternative is single point urban interchange. Again, it was produced for this group. Here is a horizontal alignment with Railroad Canyon highlighted. Here is the vertical profile of Railroad Canyon. In blue is the existing ground, and in red is the designed vertical alignment. The boxed area shows that the designed vertical alignment was lowered from the existing ground due to new I-15 bridges, which will replace the existing bridges spanning over Railroad Canyon. Here highlights the pedestrian and bicycle access paths, which are in compliance with the DIB 82-5. Here is a traffic simulation of the SPUI using the 2040 projected volumes. Here are the 2040 level of services for each intersection. We found that there was an overall increase to B's and C's in the AMP and C's and D's in the PMP. There are two APSs produced for the SPUI. First, I'll discuss the San Jacinto River crossing located here. Here's an overview of the APS we've produced. Here's a plan view, and the highlight area represents the northbound on and southbound off ramps which span over the river. And in red are the location of the vents. Here's an elevation view. This is a precast, pre-stressed box girder with 3 spans. And here's a cross-section view highlighting the new bridges. The second APS is for the I-15 bridge, which spans over Railroad Canyon, located here. And here's the overview of the APS. The highlighted area is the area for the new bridges, and in red are the location of the vents. This is the same type of bridge as the San Jacinto River crossing, but with outrigger vents. And here's the cross-section of the new bridges. The SPUI cost approximately $136 million. The total benefit is approximately $124 million. Comparing all 3 alternatives, we found that the CFI and DDR are similar in price, while the SPUI has a larger cost due to the construction of new bridges and roadway. Jonathan will now discuss the benefit cost analysis.
Thank you, Kevin. Benefit cost analysis is a systematic process for calculating and comparing the benefits and costs of a project. It has 2 purposes. 1, to determine if a project is a sound investment, and 2, to provide a basis for comparing project alternatives. The benefit cost ratio is a representation of how much the benefits of a project outweigh its costs. This table lists the cost-benefit and benefit cost ratio for each of our alternatives. As you can see, the CFI has a B over C ratio of 1.90 and the SPUI a 0.91. It's clear that the CFI produces the most benefit for the least cost, while the SPUI's benefit doesn't outweigh its investment. The cost and benefit for each alternative were 2 key factors we used to select our recommended alternative, which I'll now cover in detail. We decided to use a weighted decision matrix to select our recommended alternative. We started by listing design factors such as local circulation, freeway operation, benefit and cost, and then putting them in order of importance. We then scored each alternative from 1 to 10 as to how well they met each factor. For an example of our scoring methodology, local circulation was based on the average intersection level of service in 2040. From that data, we gave the CFI an 8, the DDI a 6, and the SPUI a 9. After scoring, we assigned numerical weights to each factor, giving the most important the highest weight. We then multiplied these weights by the scores to get weighted scorings. After totally these weighted scores, the CFI had a total of 259, the DDI 222, and the SPUI 231. From these totals, we selected the CFI as our recommended alternative. And I'll hand it over to Andy, who will cover the construction staging for the CFI.
Thank you, Jonathan. Behind any project that has been implemented successfully and efficiently was a well thought out construction staging plan. For our recommended alternative, we'll have 4 different stages that allow the contractor to work effectively as possible while having minimal impact on local access. Throughout construction, there will be 2 lanes open in both directions on Railroad Canyon Road. For our first stage, we'll be having local closures in order to improve the roads surrounding Railroad Canyon. We need to do this in order to accommodate for the widening and different lane configurations we'll be implementing in our design. In the second stage, we'll be closing the outside lanes from the northbound and southbound I-15 to Railroad Canyon Road intersections in order to start cutting and grading back the earth slopes underneath the overcrossing. Once this is completed, we can start construction of the new retaining walls that were mentioned earlier. Also during the second stage, we'll be closing the left half of each entrance and exit ramp. While the ramps are closed, we'll be adding a ramp metering system. Ramp metering helps freeway flow by limiting the amount of traffic they can enter during times of heavy traffic. Also, it allows for easier freeway merging. In the third stage, we'll be constructing the new sidewalk on the north side of Railroad Canyon Road. Also, we'll be constructing the 2 new outside lanes. Also during the third stage, we'll be closing the right hand of each entrance and exit ramp, all the way up to the I-15 in order to improve the connections. While the right half is closed, we'll be detouring traffic to Main in the north and Bundy in the south in order to allow Lake Elsinore residents continuous access to their home and community. Once that stage is done, we'll be closing the newly constructed lanes to avoid driver confusion. The 2 inside lanes will be closed as well to allow the contractor to construct the new median. The left shift lane will also be constructed during this time. Once that last phase is done, we'll be completed with the construction on the new continuous flow interchange at Railroad Canyon Road. Now I'd like to show you a short 3D simulation of traffic moving through the new interchange. As you can see here, traffic is going left using the crossover movement at the first intersection, bypassing the queue traffic and turning left easily onto the freeway. Shown here is that the east intersection is the exact mirror of the west intersection that was shown before. Now, we'd like to show you a first-person point of view as cars moving through the intersection. As you can see here, they cross over, bypass all the traffic that was said earlier, move under the overcrossing in the newly constructed lane, and easily turn left onto the freeway without having to wait for another lane. Now, Janie will go over a quick summary of our recommended alternative.
Yeah. As demonstrated throughout our presentation, we've selected the CFI as our recommended alternative. This comprehensive design has been proven to meet the needs of the city, community, as well as Caltrans. By accommodating for city development, for growth for access to the I-15, and increased freeway operations, as well as accounting for the future widening of the I-15 corridor plan, and providing safe access for bicyclists and pedestrians, this design offers significant improvement to existing conditions currently hindering the mobility and growth of the city of Lake Elsinore, as well as the I-15. This team formally recommends that the continuous flow interchange be implemented in accordance to the provided project study report. In addition to meeting all deliverables, we've also created a website that contains all pertinent information collected and created by our team. Documents and reports discussed throughout this presentation are all included. Please feel free to explore the website when you can, as we've included the link for you. Mark.
The railroad team would like to formally acknowledge the following individuals for their assistance during our project. We'd especially like to thank our advisors and mentors, John Bumps and Du Liu from Caltrans District 8, and Dr. Gia from Cal Poly Pomona. Without their guidance and dedication, we wouldn't be here today. That concludes our presentation. Thank you everyone for attending. At this time, we will answer questions.
Well, I'll start, I guess. Well, first of all, I just want to say everyone did a great job. I know it's nerve-wracking, and you're just starting your speaking tour, so I really appreciate the effort that you put into it. I think everyone from Caltrans would agree, you know, if we could hire you, we would. So I was taking notes, and I had a couple of questions, so whoever wants to I'll just throw it out there. You talked about bikes and peds, and I think on all the alternatives, they were on the north side. So are they sharing a path?
Yes, they are actually sharing a path. The sidewalk is 10 feet wide, thus having space for the pedestrians and bicycles to pass through each other.
The other question I had was, you talked about the non-standard spacing to the local street interchanges or intersections. So at Caltrans, when we process a design exception fact sheet, part of the discussion is what's the justification and what would it take to make it standard? So to mitigate that close spacing, what are some of the things that you did with your analysis, or what would it take to make those intersections all function to achieve that level of service that you were showing?
That's a fantastic question. I'll go ahead and field that one. As far as the fact sheet, it was created for the mandatory design exception. The reasoning behind maintaining it was due to the existing constraints, severe existing constraints at the site. Our justification for moving forward with it was to create an economically responsible design, while also researching and finding out safety performance of the interchange currently. It was found that all accident data was below the average in the area for the interchange, so we felt that there wasn't any sort of immediate concern for safety there. So maintaining it was something that we were okay with and were requesting a design exception for.
Okay, I guess I'm next. So, well, great job, guys. Really outstanding presentation, great analysis and alternatives. I just had a few questions. First of all, I know you rejected the split diamond, but I don't think I've ever seen the reason for rejecting the split diamond. So you can answer it now, or I can go over my question and you can answer them at the end. The second question, did you do any mainline analysis in terms of the need for auxiliary lanes, viewing analysis, merge divers, things of that sort? And the third is, I understand you picked the CFI and you provided the reason why CFI is your preferred alternative. And the simulation I saw, that was great, but you're only showing one left turn for the crossover. Is that sufficient number of lanes to meet the demands for 2040 traffic?
Okay, so I'll go ahead and field the first part of that question. The split diamond interchange was a joint effort between both teams. We took a look at separating that type diamond out to both the new interchange and the existing interchange. The reasoning that we rejected it was the fact of, again, the close intersection, the existing constraints at the site, including the existing bridge structures that span over Railroad Canyon, as well as over the San Jacinto riverbed. With an Ox Lane split diamond consideration, we would have to make significant changes to these structures, especially over possibly environmentally sensitive areas, being the riverbed. So we determined initially, from a preliminary aspect, that it would probably incur significant cost to the project. Hopefully that answers your question.
Your second question about mainline levels of service or analysis in terms of merge and diverge or median analysis. We did perform levels of service for the freeway, both existing and for the 2040 projected volumes, given the existing, or the build out of the I-15, which is 3 mixed flow lanes and 1 HOV lane in each direction. With that new addition of the HOV lane, we were still getting levels of service of F for our projected volume, from our projected volumes. Merge and diverge, because of the level of service on F, on the free mainline, also gave us less levels of service for the merge and diverge. There was no weaving analysis performed because we weren't that close in contact with the other design teams for Franklin.
And then for the third question, while analyzing the CFI through Synchro, we found that with just one lane going the left turn shift, it was adequate to provide the adequate level of service. It was above the threshold needed for no lane, but with the CFI we'll need 1 lane anyway. It was below the second threshold to must have 2 lanes or more. And through all of our simulations, AM, P, and peak, it worked fine with just 1 lane.
Great job, you guys really did a very good presentation. I know that public speaking is an art in itself, so really good job. And the material you presented was really good. You must have really good mentors. Really enjoyed the animation in presentation, especially when you're crossing out certain alternatives or using the bold font for the ones that you have chosen and you went on. It was just really good. I don't have really necessarily a question, I just have a comment. I noticed you used 20% for construction and administration, which kind of sounded a little bit maybe on the high side, so maybe you want to look into that. But other than that,
What's a good percentage to use for that particular item?
construction?
It looks like it varies.
I think personally, I think maybe 12 to 15 perhaps.
12 to 15.
Yeah. But a really good job. Awesome.
Thank you.
I'll ask a question. I don't think 20% was bad. No, I'll echo the same thing on the president. Great job, team-wise, presentation, the micro simulation, all the details. Overall, I think you guys have found out it takes a team to put all these different parts and ends of a project together, from the design, environmental right-of-way, traffic simulations and such. So, and it's the real-life situation out there. So, couple questions. I like the efforts on the ice and the technicalities behind that, and how you threw out the roundabout situation, because those things are coming out now. With the ice on the evaluations of that and the new Caltrans directives out there, they're in the process of doing a life cycle cost analysis. You guys went into the alternative of a roundabout, and then seemed to say it's a spillover and it doesn't work. Is that when you stop on that alternative? Did you consider doing a second roundabout at the next intersection, or is that as far as you went?
I'll field that question. When we did our ICE analysis, we did a combination of roundabout and signalized alternatives on a variety of intersections. And even if we have all roundabouts, it would still break down and would still cause spillover from the nearby intersection. So that's why we assessed that all intersections will be signalized for the 2040 volumes.
And this goes back to that cost, so you can probably reduce the cost of this whole interchange down to 10% that we're looking at. The other thing is, I noticed on the staging, everything was up on top, ramps, structure, anything on the main line for the staging that needs to be considered, or just gotta look at that?
For us, the only thing that even considers with the main line is the closures for the ramps improvements, and that's just going to be short-term, overnight, weekend closures. We didn't do anything with construction-wise for the main line. Our scope was mainly just the local interchange, so we don't have any construction stage or anything with the main line.
False work, median work?
For the CFI, we didn't have any false work needed under the bridge, and then the median was just on the local street.
You guys, I'm blown away. You guys did a fabulous job. Just my only suggestion, you guys have worked very hard on this. Take your time. You know, relish. You show, you know, all that effort and time you spend into it, and don't rush. Just take your time. We're here, you know, to hear it. We want to hear it. So that'd be my only suggestion is you know, take your time. It's great. Okay, so my questions have to do with the structure cost. I saw it was extremely high. and without, I mean, I don't know, just you guys chose very, what I consider expensive types of bridges, a precast versus just casting in place. Why did you guys go into precast? Also the outriggers. You know, that's in essence building another bridge. It's very expensive. What was? I just feel there could have been, we could have lowered that price and made it a better option. That's all.
That's a really good question. The SPUI, because it's an overcrossing, the railroad canyon, we didn't want to put any sort of columns within the actual travel way, lanes or anything like that for safety concerns. So we decided to go with an outrigger bend, which put it outside so traffic wouldn't hit the bends possibly or whatnot. Our structural costs were based off that comparative bridge structure sheet from Caltrans. We did look at, I think precast is roughly $200 per square foot. And we were instructed also that construction, maybe you can talk about this now, is roughly the same as cast in place. Not exactly sure if that's 100% true, but we did increase the price because of the construction staging, closing off the main line, diverting traffic onto the existing bridge while we moved the right-hand bridge, building that half of the new bridge, moving it back over. So yes, we do have a very high bridge cost, especially for the overcrossing of the San Jacinto River.
Right.
That's like an 80-foot bridge height with huge abutments and vents in the riverbed. But yeah, definitely the bridge costs are a little high, so we're probably off on that.
If I could build on that, Mark?
Yeah.
One of the reasonings as well in terms of picking those outrigger bends were just the geometric constraints of the site. We tried a whole number of different radii and so forth for the ramps that kind of spread out and kind of have those free movements. We exhausted every scenario we could think of in terms of trying to get a bend in there without obstructing any type of flow of traffic or anything of that nature. And it was decided we really need to kind of get these outside of the due to the constraints.
Okay. Oh, that's good, and that's what you want to do because it is costly, so that's great feedback. Just in the APS, it just appeared there was like a column, and then you had like a square, and then the footer. What was that square thing above the footing that I don't?
For which one?
Yes. It was one of your APS sheets. It was a typical section. You showed almost like a column flare, and then there was like a square, and then you had your footing below that.
That was the beam. That was like the support beam for the outrigger bends.
No,
That was for the river crossing? I think that was just a notation, kind of funky lines that came down that looked like a flare.
for the
Yeah, it was big.
the rectangle that's on there now. That's how it was currently given to us. We believe that it's some sort of buffering system since it's in the river, so the columns don't get washed away. In time, because our
Okay, it's more like a pier wall then.
yeah, because our area is in a 100-year floodplain, so in case something comes down, it won't get washed away.
So a couple of questions. As far as I know, I haven't seen any CFI in California, so if you have done any research of CFI has been used anywhere in the country, and you can share that. Also, second question is, you plan to share this, the city is the lead on this project, you plan to share your presentation with the city at some point and make them aware of your findings.
Absolutely. Kevin, do you want to talk for a few minutes about where some of these CFIs are located?
Oh, yes. I believe some of the CFIs are located in Louisiana, or Utah. Utah, excuse me. Utah, Missouri. Yeah, the places in Utah is around Salt Lake City, cities surrounding Salt Lake City.
Just to kind of talk about a little more about why we chose DEIs and CFIs, is not only do they basically help us with all the needs of the project, but transportation is dynamic, and we're young professionals about to enter the industry, and we want to use new and innovative techniques to meet that new demand. So we decided that, hey, look, let's look at CFIs, let's look at DDI, let's get this more implemented within California. Let's have individuals start getting used to driving these types of interchanges now. Let's start that. Let's be innovative as professionals.
I think that's great. Don't get discouraged when you hear no.
I'm serious.
Because you're going to get no. But don't let that stop you, because that is awesome. You're absolutely right. You are the future, and you need to think that way. Think of the future. So don't get discouraged when you get that first no.
In regards to your second question about sharing this information with the city, we'd be happy to do that at just a reduced rate compared to another private consultant. No, I'd be more than happy to talk to the city.
Right, and everything on our website, all documents are downloadable.
That's correct.
If you need to look more closely into it, we have a lot more detail on it.
I'll show a little bit of the website so you can see. No, maybe after.
Yeah, possibly after Franklin's presentation.
Yeah.
One more question from me. This is the question I always ask each team since 2007, right? You spent almost a year effort on this subject. At the beginning, you have nothing. At the time, zero in, no ideas. What's APS? What's EDI? What's CFI? These are some ideas. Oh, Dr. Gia's projects are supported by two wonderful, engineers from Caltrans. Oh, the opportunity is there. I want to take it. So that's kind of the time you came in at the time. Now you feel, wow, this is a job we have already. I'm glad to be part of the business. Through the year effort, what do you learn? Maybe.
Do you want to do individually?
Yeah, my one.
That's great. So, first of all, my interest for transportation began when I took Highway Design Lab with Dr. Gia. He talked very highly of his senior project team. He almost talked about them as his own children. Really just like a family effort. It was awesome. I kind of wanted a taste of that. He approached me last year and said, hey, look, are you interested in being possibly a project manager for one of my teams? Yeah, that sounds cool. I was invited to this presentation a year ago, so I was in your guys' seats a year ago today. Good luck. In terms of growth as an individual throughout the year, it took a while for us just to wrap our head around the entire scope of this project and kind of the procedure that we needed to use in order to produce such a quality product. As an individual, as a project manager, it's really hard to get down kind of in the details. I'm not doing necessarily all the traffic analysis or whatnot. So as a project manager, I've learned how to effectively communicate with my team. That's probably the number one big thing, Dr. G, effective communication, while also having a greater understanding now of traffic analysis, APS, geometric design, using the highway design manual. And as a project manager, being able to talk to Janny about environmental or Kevin about ICE and getting their feedback, and then also having a greater sense of the overall project and how that's going to influence our end result. I think having that ability to be kind of detailed and having that knowledge about how that detailed effort is going to affect the project maybe 3 or 4 weeks down the line, I think that's one of the biggest things I've learned.
Wow, it's going to be tough to follow. As Mark said, my love for transportation came with taking geometrics. Unfortunately, not with Dr. Gia, but another individual that we consulted with during this project, and just sparked my interest. The biggest thing I would say I learned was being a lead. I stood up to say, I'll go ahead and lead all geometric design, even not knowing 100%, every aspect of it. AutoCAD Civil 3D was fairly new to me, but I wanted to hit that, run. I wanted to learn and soak up everything I could as far as geometric design is concerned, and use programs that are being used today in industry and things, that they do every day. So leading my group of Kevin and Kevin has been a real valuable professional growth for myself in terms of just leading a team.
One of the big things I've learned is communicating with other teams. Me being on the geometrics team, I have to communicate with the traffic team because they would do the level of service and tell me the number of lanes, which would directly affect my geometric design. And another big thing connecting to that is time management, because traffic may have a time frame for their due submittal, and then geometrics have another time frame to get a project done.
I'll be the first to admit that when I first started this in the fall, I thought it was a little bit more than I could handle. Throughout fall quarter, we just kept getting more and more things to do, and I thought, wow, this is so much. I don't even know how we can get this done in a year. But throughout working on it, it was really great to learn how to manage my time and organize myself and figure out this is what it's going to be like in real life. In the real world, we're going to have all these projects that need to be done. There's no, well, I'll finish it a week later and it'll be okay. So just working with the different deadlines and learning how to organize myself in order to complete the project was a great thing for me to learn. Also, going in interviews and things, it's nice to have the technical aspect of all the things that we've learned here. I've noticed that talking to a few people from different schools that might have been waiting outside the interview, they haven't done anything even close to this, just all theory, nothing practical based. It's a wonderful thing to be able to have that knowledge behind us.
I'm going to start by saying I wasn't necessarily transportation when I came in. What attracted me to this project was more the real world aspect of it. I actually talked to a lot of advisors about which project to choose. I'd never had Dr. Gia before, but I'd heard many good things about him, and when Mark approached me about joining the team, it actually interested me because it was a lot of real world aspects that I get from it in addition to all the teams that I've already been a part of. But the technical aspect of being on this team was actually really nice to see, since I wasn't sure what it would be like going into industry and what you'd learn and what you'd get out of it. And talking to my friends in other senior projects, we put in so much time to this project. We're here at least 5 hours a day starting fall quarter. No one was here that much until maybe the past month. And the past month we've been here maybe 20 hours a week. So it was really rewarding and seeing every aspect of the project, and being in a group of, 8 guys here, 10 guys there, 18 guys and me is probably a lot more real world than it can get.
So what I learned a lot from this project is that be prepared for anything. Something might come out of nowhere and you'll have to work with it. We had issues early in the line, and I just had to deal with it and schedule it and put in my schedule, and also communicate effectively, saying that I'm not sure if I can make this deadline correctly, or if I did, then I had to reinforce that I was going to get it done at this certain time or whatever. And also things that come in out of nowhere, for example, would be the ice, because it's a new directive that was introduced just last year, and in the beginning we were like, just look at ice real quick, and eventually I was turned to being full understanding that directive, trying to make sure I understood what it was all about, and by the second quarter or so, I was like, okay, I think I have enough knowledge that I can implement into our analysis. So that's why I did it, and it was just, I was literally just focused on doing just traffic, and then I was given that directive, and so I just followed it. Yeah, I just learned to prepare for things for the unexpected.
For this project, I learned by far how to work in a team from any other project I've ever had. It's a year-long project. Nothing even comes close. And learned a lot about APS. I use AutoCAD again. That's about it.
So what I learned is basically what everyone else has said: communication, time and effort, how much work goes into producing a road that we drive on almost every single day. And I just learned that if you want to get something done, you have to do it as quick as possible, or as detailed and to the standard as possible.
Alright, so I selected this senior project because I also took Dr. Gia for geometric design, and I was thinking, alright, this is an interchange improvement, so it would be something similar. Because that class was a lot of work, but it was easy to understand. But little did I know, we would have to go into the environmentals of this project, the simulations, the analyzing, and it was an overload at some times, but I think it's made me a better individual at the end of the project. I'd like to credit the team also, because a friend once told me that if a project is successful, it's not really based off of the success of the project managers, but of each individual on the team. Because these are some of the most dedicated geometric designers, traffic analyzers. Yeah, that's in my 5 years at Pomona. So a lot of credit goes to these individuals standing up here. Mark and I, we managed the project at a top level basis, and I guess there are pros and cons to that. You don't really get the technical skills. I mean, some of these guys know AutoCAD, Civil 3D on the tops of their heads, and Mark and I struggle trying to find how to draw a line on the program. Whoa. But then, yeah, it's been a great journey for the past 9 months. If we had to do it again, would we? We'd have to think about it. Yeah, but it's a great experience, and I highly recommend it for the both of you students to take it with Dr. Gia.
All right, very good.